Head on Fire is a Patreon-supported podcast. Supporters of the show get early access to ad-free episodes, a private Discord server, archives, and more. All benefits are offered on a sliding scale, so no matter your level of donation, you never miss out. If you like this show, consider supporting it with $1 a month or whatever you can at patreon.com/headonfirepod. Thanks, and enjoy the show. From best-selling novels like Mexican Gothic to blockbuster media such as The Last of Us, it seems like everyone is talking about fungus. It's your house fern's spongier, creepier cousin. Fungus plays a huge role in decomposition, which adds to its macabre reputation, but it could also be a food, a recreational drug, a source of medicine, and a multi-story house if you're a Smurf. The more we learn about fungus, the stranger it gets. The largest organism on Earth is a fungus. Fungus can have thousands of different genders. Fungus breed and communicate in ways we're only beginning to understand, yet there are those who do attempt to understand. Dr. Leslie Holland is one of those people. She's a mycologist, a person who studies fungus. She joined up with the University of Wisconsin in 2020 as part of the Department of Plant Pathology. She researches the ways fungal disease affects fruit crops, and she has a teaching schedule most professors dream about. I sat down for a discussion with Dr. Holland about the fact and fiction of fungus. Here's Dr. Holland. Dr. Leslie Holland, thank you so much for being here on Head on Fire. Welcome.
Thank you. Thanks for having me.
I am so excited to speak with you today. For folks that may not have come across you or your work, your research, your field of study, tell people a little bit about yourself and what it is that you do.
Yeah, of course. So I am Leslie Holland. I'm an assistant professor and an extension specialist in the field of plant pathology at the University of Wisconsin in Madison. So my job, I like to kind of simplify and say I'm a plant doctor. So what I essentially do is I specialize in different fruit crop diseases, trying to diagnose them, understand more about the pathogens that cause those diseases, primarily fungi. And then we also try and, of course, figure out management solutions. Okay, we've got this terrible disease. Now, how the heck do we get rid of it, right? Most of the crops that I work on, as I mentioned, are going to be fruit crops. I'd say big ones for me include cranberry, apple, grapes, and then other small fruits like strawberry. So they're great crops to work on and get free benefits there.
So I feel like anytime somebody works in like literally any level of agricultural field, they have a lot of opinions about the fruit that you should or should not buy and when you should or should not buy it. Do you have a lot of opinions about the fruit that you should or should not buy and when you should or should not buy it?
No, I feel like I should because I know my mom told me things growing up and I don't know if I retained all of them in terms of like, holding the melon in the store. Like I'm not that person. I think if anything, I try not to go for the perfect fruit as someone who tends to work with all the ugly fruits because they're diseased. I try and not go for the perfect fruit, but that's hard to do as a consumer as well. It's, there's a huge bias.
So I'm so intrigued by the aspect of your research that has to deal with fungi. Now you said fungi, so now I'm very self-conscious that I'm pronouncing it incorrectly.
No, everyone says it differently, but I kind of love that. I always say fungi, but I hear people say fungi. I mean, I think it's open to interpretation. I think as long as we're talking about it.
I was at a street fair yesterday, and there was a person who I guess sells mushrooms that he forages in the forest, but he also sold T-shirts. And I knew I was going to interview you today, and I almost bought a T-shirt that said fungi, and it said F-U-N-G-U-Y, and I was like, okay, but she's got like PhD after her name, and I don't think I can go on to a professional interview and wear a shirt that says fungi. But I just want you to know I was thinking of you yesterday when
I love that. No, you should have. I always make the joke that I'm a fun gal. So, I think it's totally appropriate.
So I am very intrigued by the aspect of your research that specifically has to do with fungi because strangely enough, fungi are kind of having like a moment in pop culture in recent years. It's fascinating. But before we get to that, so I feel like when people think of mycology, specifically that field of studying fungus, we think of just its botany, but for sponges, like really spongy botany. So is there something different that we should be thinking when we think of botany versus when we think of mycology specifically?
Yeah, I mean, I think for me, I'm fortunate and I get to kind of work where they intermingle, where plants and fungi meet, usually kind of on the bad side of things, unfortunately for the plants. But yeah, I think right there are these really unique fields. Botany is all very plant specific, and mycology is fungal centric. And I think when most people think of fungi, like when I tell people I work on fungi, they're thinking of these like big mushrooms you see in photos or cartoons, or maybe in the woods if you're foraging. But that's just a very that's just one group of fungi, a very small class of fungi. There are so many other species that most of us end up working with and researching that they don't even form a big mushroom structure like that. They form much smaller spores, reduced fruiting bodies on little pieces of leaves or woods or things like that. So they're really diverse. And I think that is often misunderstood about fungi a lot of the time. But yeah, you completely different fields. Plants and fungi aren't really all that closely related anyway, so it's good to make the distinction.
Now, speaking of things that are related, I don't want to spend so much of this interview going like, hey, I found this weird, stupid thing on the internet. Tell me whether or not it's true. Unfortunately, a lot of this interview may very well be that. Because there is so much weird information out there about fungi, and I've never gotten to speak to a mycologist before. So this is just my weird personal, I mean, just forget that thousands of people are listening around the world. It's just you and me having a conversation. I get to pick your brain. Is it true that fungi are technically closer to people than plants?
Yeah, so that actually is true. So fungi are more closely related to animals, than they are to plants, which is crazy because again, it seems like generally speaking, it seems like they should be in the same category. They're small, they grow, but they're really biologically quite different. So I'll explain it this way. So plants, right, they make their own food, right? They photosynthesize, they use that to make their own sugars. They're producers. They're taking care of themselves. They don't need nobody else, right? Fungi, animals, on the other hand, they're consumers. So just the same way that animals have to eat plants or other producers or consumers to get their food, fungi have to do the same thing. Fungi cannot produce their own food. So they're very much like animals in that sense. They have to benefit off of another plant or an animal to get their own source of nutrients. And so beyond just kind of that difference between plants and fungi, they also, so this is really interesting too, in terms of kind of like an evolutionary perspective, right? Like however many years back, they diverged from a very similar ancestor. And so we're going to get into a bit more biology, but we'll keep it fun. There's this group, this really large clade called Opiththeconta. And essentially, this ancestor has what are these kind of posterior flagellum. So think for animals, think of sperm. They have a little flagellum, it's swimming around, moving around. Fungi also have a very similar mechanism for moving their spores around, kind of very ancestral look at fungi. That's how they're able to be motile and move around. So that's kind of another way that fungi and animals have this kind of close bond or similar ancestry compared to plants, because plants don't get around in that way either.
I suddenly feel very weird about eating deep fried mushrooms.
Too close to home.
I suddenly don't know how I'm supposed to feel about that. No.
I know. I think we have to embrace it. I really like mushrooms, not just because I work on fungi. I genuinely enjoy eating mushrooms. But yeah, I know when you think about it from kind of that evolutionary standpoint, it does feel a little disturbing. But there's still a big distance, right? I mean, those are very kind of like things a long time ago that they had in common, right? I think we've had a lot of divergence since then. So
I like that my brain, when you said, okay, but they are like people, but there's a lot of distance, my brain immediately brought up the phrase kissing cousin. So it's like, okay, it is your cousin, but it's so far enough away, it's still okay. Okay, they are like people, but they're far enough away, you can eat them, it's fine.
Yeah, you can totally eat them. They're delicious.
So when we talk about plants and when we talk about fungi, when we talk about things in the natural world, we tend to be very human centric when it comes to those conversations. We tend to talk about trees in the sense of they provide us oxygen. They remove carbon dioxide from the air because we don't like it. For some reason, we're very human centric. Everything is made for us. Very Garden of Eden about the whole thing. But so if we are thinking of maybe ecosystems, but removing the human-centric part of it, what is the job of fungus in the wild?
I love this question. Yeah, I think fungi probably some of the hardest workers. They have so many different jobs, some that benefit us, some that totally put us at a huge disadvantage. So I can kind of talk about both of those things. I would say probably what they're, best known for besides looking cool is they're decomposers. They're really good at decomposing in the ecosystem. So they can break down dead organic matter, such as like wood or, leaves in the fall, right? Even dead animals, they can help break those down into simpler compounds, helping recycle those nutrients and then making them available to other organisms at some point in that kind of life cycle process. So benefits us, but also benefits them because they're getting that food source. Some ways they can't benefit us, and in fact, probably the main way that I study in my research is pathogens. So they're pretty bad too. They impact plants of all different species, especially our food crops, which is what I primarily study. So they cause diseases. They can also, of course, cause diseases in humans, right? I think of things like ringworm, gross, had it before, totally sucked. Athlete's foot, yeast infections. It could even cause even more serious diseases that we hear a lot more about, I think, in the last couple of years in terms of yeast infections in hospitals. So yeah, they benefits to us, no benefits to us. They also provide things like food, right? Baking goods, wine, beer, all the good stuff. They also have a lot of benefits in biotechnology, I would say, too. I think one of the oldest ones is probably the penicillium fungus, which produces penicillin, right? So I don't know, they do all these incredible things. They can make medicinal compounds, psychoactive compounds, right? I think that's probably grown in popularity, too, in terms of talk about that. So they do everything. I can't think of something that they don't do. I guess they don't do taxes, so we'll have to work on that. But they really do everything.
Though I feel like if certain legislators hear this interview and they think, well, they're close enough to people, maybe we should
They
make
should be
them
doing
pay.
taxes.
They should
Oh,
be
no.
paying their own taxes.
I'm sorry, Fungi.
So it sounds like they do a lot of things out in the world. Would do we are we? I don't know how to ask this question in such a way that it doesn't sound human. Such do we impact them at all? Like, are we? So I think of a lot of different kinds of, I'm thinking of global warming. I'm thinking of climate change. I'm thinking of man-made intervention. I'm thinking of all of the kinds of ways that we are harming and helping different kinds of environments. In your study of fungus, how does our interaction with is they seem pretty fine. Are they fine or are we screwing them up?
No, that's a really good question. I mean, I think maybe a little bit of both, but I think in some of the ways that we're screwing them up, we're actually making it harder on ourselves. And so I guess what I mean by that, so they're ubiquitous. They're literally everywhere. I always joke with people, like if I were to like take a swab of my arm right now and culture it, we'd find a bunch of stuff. Not because I
don't like
have,
that.
I know.
I don't like that, Dr. Holland. No, thank you.
I know.
No,
Okay,
thank
we'll
you.
pretend it's just my arms then. So, so right, they're everywhere, and so they're ubiquitous. And I think in some ways they're really resilient. So somewhat hard to destroy. But in systems like what I work in, where we do try and get rid of them and kill them, right, using different things like fungicides, that can get rid of them. So that has a huge impact on these fungal pathogen populations, right? When we're making these applications to protect our food crops, these fungicides are ideally killing them or really significantly suppressing them so that we don't have to deal with them, which is great for us, bad for them. But as we've started to see in agriculture, there's this little unfortunate thing called fungicide resistance, or pesticide resistance for that matter, where the fungi that were previously really responsive to these chemistries, that were responding like, oh no, I'm about to die, are now like, is that all you got, kind of a thing? It's just, I'm oversimplifying it, but I think that's kind of how we have to think about it. This wave of pesticide or fungicide resistance is a huge problem now. We've had these chemistries that we've been fortunate to use that are really effective, but unfortunately these different fungi are kind of learning how to respond or not respond to these things in the same way that they used to. And so that creates an even larger problem for us.
Do plants learn the same way that fungus learns? Because, I mean, obviously we have, weed killer and various, plant killing stuff. And I don't see like weeds suddenly taking over everything and getting so strong. Or do they? I don't know. Maybe I'm an idiot.
No, they do as well. I mean, that's not an area that I study, but there's definitely resistance. I guess that would be herbicide resistance for weeds, and weeds can respond as well and adapt and say, oh, this chemistry is not working as well as it used to because the weed has somehow had a mutation or an adaptation that it no longer responds to that chemistry in the same way and can overcome it. So yeah, it happens in weeds, it happens with insects, it happens with pathogens. It's pretty detrimental. I'd say this area has gotten a lot more study by a lot of us researchers because it's such a growing concern when we have these tools that have been effective for so long. And now we're starting to see sometimes failures or just documented resistance in the lab to some of these chemistries. So it's definitely a huge area of research, a really fascinating area of research.
One of the other interesting questions that I have seen kind of thrown around on social media, on the internet, and in various places like, did you know? When it comes to the concept of just like our understanding of fungi, inventing entire new words here,
Yes.
of fungus and the way that they procreate, the way that they kind of exist out in nature. Obviously, humans, again, are very human-centric. We think of everything as either male or female. And obviously, modern science is telling us that there are lots of different ways to be a person that don't necessarily involve one of those dichotomies. But when we look at the plant kingdom, the animal kingdom, when we look outside of ourselves, we tend to project those labels onto that. And one of the kind of interesting facts about fungus is that the more you try to do that, the less it works. And something that I've heard, and I would love some more information on, is that fungus has like tens of thousands of genders or sexes. Is that true? And why are they so freaky? And I'd like to know more about that, please. Thank you.
I've never heard of that, but I think it's really fascinating. And I think, so fungal sex reproduction it's super fascinating. And there's a trillion ways I feel like that they can go about it. And a lot of it just has to do on like their environment or what they're going to get out of it, right? What's the benefit to them and how they're going to reproduce? What's that going to get them down the road, which I think is super fascinating. So I think the way that we really think about fungi kind of generally speaking is we have categories of sexual reproduction, which again, from the human animal centric side, we're very familiar with. But they also do asexual reproduction, which I think is super fascinating. And in fact, most of the fungi I work on, we're not even actually able to find a sexual state in nature for some of these fungi. So we've described it, we've given a name to it, but we can't find it, which I think is so fascinating. Or it's been reported once, like 50 years ago, which is wild. So they typically reproduce asexually. And I think from the benefit of the fungus, that's a really effective way to do it because you're able to produce really quickly. So what I mean by asexual reproduction is essentially for a lot of fungi, they produce spores so they can sporulate. And so one spore gives rise to another spore sometimes, or there are these structures that give rise to a bunch of different spores. And they don't need any type of mating or, male, female sexual cells meeting. It's just like clonal propagation of these spores. And it allows them to be really successful in terms of those spores being produced, wind or rain, thinking in agricultural systems, taking them and introducing them to a new host. And so a lot of the common, like, if you see, I'm trying to think of a good example, like if you had some bread that got moldy at home, those blue spores that you sometimes see, that penicillium, that's asexual reproduction. Those spores are what we call conidia, and they can just move around pretty easily. And as you can see, it causes quite a bit of mold. Yeast do budding, which is a different type of reproduction. It's asexual. So that's where literally a parent cell gives rise to almost a little baby cell, if you will. No sexual recombination involved in that. It's just budding from like a source parent. And then the sexual reproduction is pretty diverse as well. They have gametes, they have mating types, which I think is really fascinating. And so a lot of work that can be done in fungi looks at different mating types. So is this one compatible with this one? It's like fungal dating almost. And sometimes you don't find your match. That's the reality.
Those poor mushrooms. We need some kind of mushroom Tinder.
Right. It's fascinating stuff, though.
So I'm curious about your specific area of research. You said that we were talking earlier. You said you take students around and see if your crops died from fungus or something. They rotted. I'd like to hear more about your specific area of research and what it is that you're looking into.
Yeah. So when I teach every other summer right now.
Mhm.
And when I do that, essentially, it's a field class, which for me is the best type of teaching that I'm able to do because I get to actually bring students to the field. We're not just in a classroom, we're actually going to see this plant disease on this plant. And I think being able to get that concept visually versus just in a textbook or a lecture that I show you some pictures, it's completely different to see it in person. And then we're actually talking to people who are affected by disease. It's not like, oh, hey, look at this thing. Ooh, it's scary. Okay, let's turn away now. It's like, let's talk to the people that are actually impacted by this disease, which are our farmers and our growers and other folks that are in extension and other stakeholders. So that's part of the teaching that I get to do every other summer, which I really enjoy. And then my program is really centered on a lot of fungal diseases of fruit crops. So cranberry is probably the main crop that I work on. And we study a fruit rot, what's called a fruit rot disease complex. And it's over 12 different fungal species that essentially cause our beautiful cranberry fruits that we will probably be eating in about 2 months to rot and be disgusting. So I try and prevent that from happening. And so a lot of the work in my lab tries to understand how these fungi are interacting with the cranberry fruits. When rot develops, what are the things that contribute to that fruits getting disgusting and rotty, which I love to see. No one else does, but that's my job. And we study other fungal pathogens in grape and apple as well, but a lot of it's focused on diagnosing what causes the disease and then trying to understand how that pathogen, that fungus interacts with the plant. Does it kind of do so incognito? Is it like going under the radar of like, you can't see me, you can't detect me? Or is it coming in like, hey, and they have these different strategies. So I think trying to understand the biology, and then ultimately once we understand that about the pathogen, we can determine how to best manage it. And there's just really a lot of diverse ways that these pathogens, these fungi, can interact with plants, and it's fascinating. Some, like I said, are really stealthy. Some, kicking down the door, no introductions.
So you said trying to prevent some of that rot from happening. Is this like a commercial application? Like you use your research to help inform some of those fungicides? Or is it like,
yes,
I don't know, we're trying to find okay.
So we do some of that. We do test different chemistries to see what can prevent these fungal pathogens from developing. We also look at things like even environmental factors.
Mm-hmm.
A lot of the times these fungi, right? The same way that for me, I'd prefer a nice day when it's about 75 degrees, low humidity. Fungi have preferences too. If it's going to be really dry outside or really cold outside, a lot of the fungi are like, no thanks. Like for a lot of fungi, that's not a conducive condition for them to spread and cause new infections. They're waiting for what their optimal conditions are a lot of the time in terms of their movement and infection. So we really try and spend time understanding those factors and how that contributes to diseases developing so we can manage them, right? We don't have control over the environment, but if we can target the time when the fungus is the most happy and wipe out as much of that as possible, that's what we try and do essentially to simplify things.
You heard it here first. Dr. Leslie Holland is officially the fun killer when it comes to fungi. She tries to keep them as miserable as possible.
I do.
That's her entire job.
I do. No, that's so true.
So, speaking of kind of keeping it in that optimum temperature, going back to pop culture for just a moment here, we have. So, I think this is so funny to see how this has grown and spread like a fungus. Like I feel as though about 10 years ago or so, maybe a little bit more, maybe a little bit less, there was this Facebook post. And it went incredibly viral. I feel like this is the first like infographic Facebook post that went around that I distinctly remember. And I thought somebody somewhere is going to do something with that. And it was about cordyceps making zombie ants. And it was that I mean, I can still picture the photos that they used in the Facebook meme in my head. And I thought somebody somewhat that would make a good story. And apparently I was not the only one that thought that would make a good story.
Yeah.
That exact plot has shown up in books like Mexican Gothic. It has shown up in video games and TV shows like The Last of Us. It has shown up in all sorts of medias, like very specifically cordyceps taking over humans and becoming a whole thing in some different kind of way. And apparently to achieve this, climate change made it warmer or something. And so the cordyceps evolved and that happened. So when it comes to zombie ants and cordyceps, what's actually going on there? Is there any scientific basis for any of this? And I hate that I feel like I have to ask this, but what are the chances that fungus are going to take us over and become our new overlords?
I mean, that's such a tricky question for me as someone who really admires
No, the
fungi. No,
answer
I know.
is there is
No,
0%
I
chance,
know.
Dr. Leslie Holland.
I know. I
Any
know.
other
I know. You're
answer
right.
other than that terrifies me.
And that wraps up the podcast.
I will be moving to my bunker. Thank you and good night.
No, these are good questions. And I think, yeah, the last couple of years, there's been so much attention on fungi and excitement to talk about fungi, which I think is great. But okay, so backing up, yes, the zombie ant fungus, totally real, totally wild. I remember when I first learned about this and I thought that this was the coolest thing I've ever heard of. It almost made
Yeah.
me feel like the fungi I work on are lame because they can't do mind control. And I was a little bit like, wow, okay. But nonetheless, so yeah, it's a real thing. So we call it the zombie ant fungus cordyceps, right? They infect these ants. They essentially spread throughout the ant's body, taking it over, and they just take. It's like they're taking over the brain, right? So the ant is still able to kind of be alive, but it's totally manipulated and controlled by this fungus, which is, I know, it's really wild to think about, but it's a pretty interesting strategy. We talked a little bit about spore dispersal earlier. So this fungus is infecting this ant. It's taking over its brain. It's encouraging the ant or kind of forcing the ant once it's infected to crawl up, like a blade of grass or something tall so that it has the best opportunity for its spores to spread even further, right? Because if the ant just stayed on the ground, that's not a lot of spore dispersal for this fungus. The fungus is like, no, I'm going to be smart about this. I'm going to go to the top, bring this ant to the top of this blade of grass or whatever, and that's going to allow me further spore dispersal. It's pretty impressive. It's really impressive.
Okay.
It's scary.
Okay. So the fungus thinks? The fungus can think?
Oh my gosh.
Because the fungus takes over a brain and is like, climb, keep climbing, keep going. Like the fungus is sending brain
chemical signals.
I don't like this.
I know, it's really terrifying when you really think about it.
Like this.
It truly, it's terrifying, but it's also really impressive. I mean, can't.
It's very impressive. It is. I'm scared now.
Yeah, but there are other. I mean, I hate to even bring this up. It's not.
Does this affect literally any other animal species? Is it only the ants?
So ants are the big one. I'm not sure the host range of cordyceps, but I will say that there are other fungi that produce toxins that can cause not great effects in like animals. So some fungi can produce toxins that cause animals like it gets in their feed, their food, to vomit. There's all sorts of, there's a lot of things like this that exist. I think there's been more recent attention on it. I know it does feel terrifying. I don't know if I have positive news for you in terms of thinking about the future. I don't think we're going to be taken over by fungi. I remain optimistic that that's not going to happen. But I think when we talked about earlier how fungi and animals are more closely related, that makes managing them from like a human standpoint a lot more challenging. So because we have more, quote unquote, like similarities or evolutionary backgrounds with fungi as animals and humans, a lot of the things that we would use to target, fungal diseases could also have off-target effects on the host that we're trying to treat, right? So it makes where we can think of something like an antibiotic for a bacterial infection or even antivirals, right? We know about those. Those are really well researched and understood for the most part. The fungal medications that we get for like human diseases, there's I think fewer of those because we have that closer kind of, I shouldn't say relationship, but kind of closer ancestry with fungi. So it makes kind of having those medicines available a lot harder because they can have these off-target effects because us as the host or animals as the host are much more closely related to those fungi.
Yeah, I mean, antivirals are the easiest, but once you get into like antibiotics and antifungals are difficult because you're dealing with living or near living things, right? So basically you're just trying to turn your body into an inhospitable environment. Is that?
Yeah. A lot of, you absolutely are. And you're trying to be causing, death, suppression of these infections, which can be really difficult to do. I mean, of course, even bacteria is a great example of, we see antibiotic resistance, right? That term gets thrown around a lot, I think, too. And that's an issue. The same thing can happen with fungi. There can be antifungal resistance to antifungal medicines that we as humans might take for something. And I know that's been documented in some case for some like yeast diseases, like even a yeast infection. There might be some medicines that folks get that you could have a resistance to that. The fungus, that yeast could have a resistance to any type of medicine. So these things are already happening. It's quite frightening from a human standpoint, to be quite honest with you. Not to try and scare anybody, but I think it's something we have to be really candid about because of that relationship.
I was thinking about, just fungus that makes the news. And I don't know how this immediately skipped my mind, but I was just thinking of psilocybin, which I feel like has gotten so much coverage, and I don't know how I missed it at first. But like, I mean, that is attributed as anything from like a wonder drug to a cure-all to the reason why humans evolved. Was the truth about psilocybin? Do we owe our entire human evolution to psilocybin? What is it, and what does it do to us when we interact with it?
That's a big question. I don't even know if I have the expertise to answer that question, quite honestly.
That's fine. If you don't, that's okay.
Yeah, there's a lot of research on psilocybin that I've seen come up lately, which I think is great. It does seem to be kind of a new tool that folks are able to use to, maybe alter state of mind or something like that. So yeah, it's not an area that I study, but I certainly see a lot of research coming to the forefront about it.
Now, speaking of research, or is there any, exciting, burgeoning or emerging research in your field that you're excited about that maybe people haven't seen because fungus doesn't always make the front page?
That's a good question. Yeah, fungus rarely makes the front page, although I think you said it's kind of having a moment right now, which we'll take for as long as we can, I suppose. Yeah, there's a lot, I think, in fungal biology and mycology that's really interesting right now. I think in terms of biotechnology, there's a lot of applications from medicine to even I know certain companies use fungi to produce just material, which like just kind of standard material. They use fungi to do that, which I think is really impressive. I've seen it, I think, in like not coffee, but maybe coffee. Like it has all these really interesting uses recently. But one that I think is really cool, and again, coming from more of an agricultural kind of background and perspective, is mycorrhizal bioremediation or myco remediation, which is where, so mycorrhizae fungi are these fungi that have these kind of really close relationships, these mutualistic relationships with plants. They can help the plants essentially obtain more nutrients, and the plants, or the fungi in that relationship are getting sugars from the plant. And so they've actually found that these associations can actually help kind of bioremediate, or in some ways kind of detoxify these heavy metals that might be in the soil. So these mycorrhizae can give plants a greater tolerance to different heavy metals that we might see in the soil. They can also help plants access different parts of the soil to, in some ways, kind of avoid some of the heavy metals that they might be exposed to. And so I think that's a really exciting area of just kind of the benefits of fungi. Again, it's very human-centric in that way, like what benefit are we getting out of that? But I think it's a really important one. I think especially as someone who works with fungal pathogens, I often talk about the bad that they do. So when I see that they're doing good, I'm definitely here to be excited and amplify that for them.
I think I saw some research in the last few years that there's been a lot of discussion, a lot of advancement in trying to use certain types of fungus to break down some of our trash. Again, a very human-centric application, but there's a lot of attempts to try to stick some mushrooms on it and make them eat it.
I like that. Stick some mushrooms on it. Yeah, that's true. We're taking advantage of that natural ability that they have to break down things, and they're quite efficient at it. So yeah. They do everything. I'm telling you, the busiest microbes.
Do you have, so there's a lot of different kinds of mushrooms out there, and some of them eat things, some of them take over ants. But there are some interesting mushrooms with some interesting superpowers out there. Do you have a favorite one? Do you have any that are just kind of spark your curiosity?
So I used to, when I was in graduate school, I did both my graduate degrees out west in Washington and California. I used to go, on fungal forays. I would go mushroom hunting, and I miss doing that. I'm sure I can still do it here. I'm just, a little busier these days. But I loved mushroom hunting, and I love eating them. Now, here's the tricky thing, I think. I would not consider myself the best at mushroom ID. There are a lot of mushrooms that have kind of these like mocking species, a species essentially that look like the edible one, but they're not. They're highly poisonous. So really important that if you're going to go on a fungal foray and go mushroom hunting, to know what you're actually looking at. And in fact, I'd probably have someone who has a lot of expertise in that, because some fungi, while they're very delicious, some are incredibly poisonous and can kill you. And that's really unfortunate. So I do like to eat them. I would say some of my favorite, I think morels are one of my top favorites. I think a lot of people would probably hopefully agree with that statement. They're pretty popular. Another fungus I really love and I think is beautiful is called a black trumpet. I don't remember the genus and species, but it's a black fungus and it has kind of this little slightly ribbed pattern. I don't know. They're beautiful. They're just like this jet black fungus. They taste really delicious when you cook them up. So I would say those are two of my favorites. Is that the one that
drips like the ink or whatever off the side?
No, but I know what you're talking about. Yeah. No, that's very interesting too. Yeah, there's so many.
There's
and
so
we only
many.
know a fraction. We only know a fraction of the fungi that exist. I mean, we know what, 100.
Does that excite you or terrify you? Because it feels like the more we learn about them, the trickier it is, and the more we're like, well, is this one going to kill us, or is this one going to save us, or is this one going to do literally nothing? And there's only those three camps. It's either going to kill you, it's either going to give you some kind of superpower, or it's just going to chill.
It certainly feels that way. That's a good question. I've never thought about, as we discover more fungi, if that could potentially be bad. I'm always maybe overly optimistic as someone who likes fungi.
You know what?
I guess it does scare me a little bit.
if you are optimistic, then I should be optimistic, because I feel like when you talk to specialists in certain fields, it can sometimes feel a little scary. I feel like it's the same like when you're on a plane and you hit turbulence, you should be looking for the flight attendants, and like if they're fine, you should be fine. Like if they're not freaking out, you can give yourself permission to chill. So if you're fine, I feel like I can be fine with fungus. I think if I see you on social media freaking out, then I am going to go live in my bunker.
Yeah.
My antifungal bunker.
That's right. Yeah, just wait for that that social media post to hit, and then But no, I feel optimistic because I think everything is an educational opportunity. And I think, as much as I work with the quote unquote bad fungi, I get to work with a lot of good fungi too. There are a lot of fungi that are, I call them the good guys, that are antagonistic to bad, quote unquote, the bad guys. And so that's exciting to see. So I think a lot of those discoveries can still be really beneficial, can help us deal with really nasty pathogens that currently exist by having these really beneficial kind of biological control-esque fungi. So I think, I'm going to choose to see it in a positive light. Maybe there's going to be new mushrooms that get discovered that taste really good too. So, we'll stay optimistic.
This might be outside of your area of expertise, and if so, that's totally fine. I had a friend ask me today, because she knew that I was going to interview you. She said, I've always wanted to know, is it true that there is a fungus out there that can make you allergic to yourself?
I've never heard of that. That makes you allergic to yourself.
Yeah, and she said it, and then I Googled it, and I don't know. The internet is a very strange place, but it does say that there's a fungus that can make you allergic to yourself.
Well, I'm definitely going to look this up.
Okay. Can't wait. Thank you. It's fine. I appreciate it.
That's wild. So maybe now I am terrified.
Well, I guess you haven't
way to change that. Yeah. Okay. Ignorance is bliss.
You haven't encountered it yet, so you're fine. It's fine. Okay, it's not out there with the cranberries, I guess. It's probably fine. Yeah. So cranberries are not going to make you allergic to yourself. At least we can
we're
establish that. Yes. Is there anything that people don't know about your field that you wish that they would ask, that you wish that the average person knew?
Oh, that's a really good question. I think in general, working in agriculture, I think understanding where our food comes from is really important, and also understanding all the inputs that get the food to our grocery stores or our farmers market or wherever folks are able to get their produce and their food. I think there's just kind of this assumption. It's like, oh, it's always going to be there and it's always going to look really good and it's going to be in this great condition. And I think, ideally, yes. And I think a lot of the time it does, but there are so many things that impact agriculture, especially diseases. And in fact, fungal diseases are the main disease issue we deal with when studying plants, right? We see a lot of viral issues in humans, bacterial issues in humans, but fungi are the big thing for plants. And so I think a better understanding of that, or folks kind of having a better maybe interest in learning more about the inputs that go into agriculture and what allows that, those beautiful bananas to end up in the grocery store, those delicious looking apples, right? There's a lot of inputs before they get to the actual grocery store. And I don't know, I think it doesn't hurt to educate ourselves in that arena and understand all the inputs that growers and farmers are making to make that all happen.
Well, Dr. Leslie Holland, I have just enjoyed all of my time with you. I can't believe we were able to get through so much in such a short amount of time. If anybody is interested in learning a little bit more, getting a little freaky with fungus, where should they start? I know that this is a big field, and you mentioned earlier that foraging is kind of becoming a very big thing, and a lot of people are becoming more interested in fungus, not just because of pop culture, but maybe also to go out there and eat it. So do you have any maybe sources that you look to, or that you could guide a beginner to start learning more about, maybe the science and the edibility of some of this?
Great question. Yeah, there are plenty of guides that you can purchase books for, and the guides for like mushroom hunting, they'll vary by your region, right? Because there's going to be a diversity of fungi that are here in Wisconsin that maybe aren't out west or out east. And so any of those guidebooks you could probably find just by doing a quick search online and order and get a nice hard copy sent to yourself. That's a great way to start. There's also, at least here for us in the US, the Mycological Society of America. They have a website. They do all sorts of meetings and I think provide a lot of educational content. So if you really want to get kind of into the meats and potatoes, the fungi and potatoes of all of us, that's probably a great place to start in terms of kind of a broader area to get that information. And the other thing I've noticed too, a lot of groups have started to form across the country of these groups that go out and do fungal forays or mushroom hunters. And they tend to have folks who have been doing it for a long time or have really great experience in mycology. So those are great things to look into too.
Well, I really appreciate it. If people want to follow you to find out whether or not you have discovered the next great fungus, are you on social media? Where can people find more of you?
Yes, I am. Yes, I'll let you know with my social media post where we're at. So folks can find me on Twitter, or I guess X now. I've got to catch up, and I know. I am at Leslie Holland _. So I usually post pictures of pretty healthy plants sometimes, but mainly not. You can follow me there. Occasionally you'll get a photo of my dog.
I'm not always a bummer, I swear. I post edible things, guys.
Right.
I swear.
Every so often.
Twice a year.
Once
or twice a year.
A healthy fruit sneaks in there.
How'd that get in there?
That's right. Exactly. So you can follow me there. I usually post about what my lab is up to. And that's about all the social media I think I can handle at this stage in my life.
That makes sense. So. That makes total sense. I really appreciate it. Before I let you go, if you had to be turned into a mushroom, which mushroom would you want to be turned into?
Oh my gosh, that's a really good question. I think I would be. So have you heard of the armillaria fungus?
No.
It's like one of the world's, I think at least it had that claim to fame. I don't know if that's still true now. I guess I should. Like the world's largest living organism.
Oh, is that the big orange one?
Yes.
Yes.
Yeah. Yes. I think that's pretty awesome. I mean, it's a pathogen, so, that's not great, but it's beautiful. It's massive.
The honey fungus.
Yes, exactly.
The honey fungus. Yeah.
So it sounds sweet, but it's actually just devastating. So.
That's wonderful. That is a perfect answer. Dollar Holland. Dr. Holland.
That works too.
Dollar Holland is the name you use on Friday nights. Dr. Holland, thank you so much for spending some time here with me. I really appreciate it. Thank you so much.
Absolutely. It was my pleasure.
That is going to do it here for this episode of Head on Fire. My thanks to my guest, Dr. Leslie Holland, who you could find in an orchard near you studying why the fruits are going bad. If you like this show and you want to support it, there are a number of ways to help. Consider sharing it with your friends on social media. You could also like or rate the show 5 stars on Apple Podcasts or Spotify. And while you're there, consider leaving a review. A review of any size or style or emoji usage, literally anything, helps recommend the show to other listeners like you. If you hate the ads at the beginning and end of each episode, consider joining my Patreon on a monthly basis. Patrons receive additional audio and video content, as well as archived episodes, a private Discord server. You guys get to help me decide what questions I ask upcoming guests, and other fun goodies along the way. You can sign up at patreon.com/headonfirepod. If you'd like to connect with me on social media, I am at headonfirepod on, are we still saying Twitter? I'm going to be real honest. I'm not on Twitter anymore. But Instagram, TikTok, very much a blue sky, and I suppose Threads, because it exists for me, because I have an Instagram account. Anyways, find me on there. I'm there. You can message me. Or, of course, I don't usually talk about this, but you can email me at contact@headonfirepod.com. Thank you all so much for tuning in and downloading the show. I'm going to go, but please remember to never stop seeking illumination like a man with his head on fire seeks water. Be well.